Okay, we're back. Thank you so much, Eric. I hope you managed to check yourself, presenting this really interesting analysis. Thank you for doing that. Thank you for sharing even the raw data and codes. So I was trying to jump in and out and see if somebody's following while you are talking, and I think it was pretty intensive, but nevertheless super important. And now is also the option to go back and track step by step what you basically showed. So it's, I think, a very hands-on session. More than that, it's harder, or would be hard to conduct. So thank you once again for doing that. And I'm actually opening now this paper for questions and discussion. I have here with me Klaus Grammann from Technical University from Berlin, and Andrei Olenschek from Rehabilitation Center Socha, and we will try to summarize what we learned today and somehow show what are the future directions. Not so future, it's tomorrow and after tomorrow, but still how to connect these biomechanical issues with EMG and then EEG. So what we've learned today, I hope you got this impression what is the basics of biomechanics, how is it structured, like from kinetics, kinematics, and then part of EMG. There is still no EEG inside this analysis. I guess sooner or later we'll be implementing in books also parts of EEG or FNIRS. But somehow we are kind of always constantly running in between. So the complexity of the setup, and on the other side some simplicity or mobility of it. So can I ask you, Andrei, what is your opinion about it? So how complex this system should be? Because I got some information that Viken, for instance, was introduced in 1979. So it's been a while since we are using this system. Now, from the other aspect, we have inertial measurement units, which actually exploded in the last years because of the development of the smartphone and tablets and so forth. So each of the tablet has this inertial measurement unit inside, so accelerometer, magnetometer, and gyroscope. So where are we currently? And looking from the clinical perspective, would you simplify your measurements currently, or we should stick still with that complexity?
Right. So I would say that placing the markers and placing the EMG electrodes takes a while in the clinical gait analysis. So this is quite time consuming, which in some particular cases it's a bit strenuous task. So of course we would like to go into the direction where this could be shortened. I know that there is, well, if we stay in the Viken, for example, now, I know that there are some initiatives or the efforts in the direction where the gait kinematics would be measured only by videotaping the gait, and then of these pictures then to actually calculate the joint kinematics, so the joint angles and so on. So this is one direction. And I think that Viken is trying to go in that direction, because I think that they purchased one of the company that was already developing this kind of technology. I'm not sure how far this is in terms of the development, the accuracy and repeatability of the measurements, but I think this is a promising way to go. I also see, I was using in my research work also the IMUs, and I think that of course they are quite useful, because the time that you use to place them on the human body shortens quite dramatically. So in Vicon you have to be quite accurate where to place the markers. But if you have an experienced therapist, that is quite significantly shorter.
Yep.
I'm not really sure about where the accuracy is between these two systems. So, but in the gait analysis, what we usually want to measure is how, not every change in the amplitude of the certain movement. What we want to measure is how the patterns change. So, in what way the patterns completely change, not just reducing by 2 degrees, for example, the knee flexion or something like that. And I think that even if you have the IMUs, these data could also be extracted from this kind of system. The problem is then whether this data can be used for clinical practice.
Yeah.
I'm pretty sure they can be used for the research. I'm not sure about the clinical practice.
Thank you. Klaus, can I ask you to comment on that? And perhaps we all use now the gaming technology. So the gaming technology kind of like came into the market. We are users now of this gaming technology to track different body positions. But how do you see it like in the MOBI research? Like this gaming market is reliable enough to kind of like implement it inside our research? Do you have any hands-on experiences, or it's not reliable still, and we're not there yet?
That's a very good question, and I can only refer to the systems that we have been using in our lab to play around with, and a few of them are very promising. So we've been playing around, for example, with the Kinect, and as long as the sensor is in the range, or the hand is in the range of the system, basically that works well enough, at least, but it comes with a lot of problems. So, and again, I'm coming back to your introductory statement. It's like it's starting from very complex technical setups that allow us to investigate with high reliability and robustness the effects that we're interested in. We can move towards more mobile, portable, easy to apply systems that are faster and can be used in clinical context too. So in that sense, there is a wide range of options, and I would argue that some of the gaming systems might be useful in the lab, but they are definitely worthwhile exploring in applied fields, for example, in clinical research. So for me, the question really is, can we extract in basic research settings, can we extract parameters that are robust enough that we can translate them to portable, lightweight systems in clinical practice, for example? So if you're not really interested in the basic principles, but just diagnostic tools, for example, these systems might work well enough to be used.
What is your opinion about that?
To be used in the diagnostic process?
For example, yes.
Well, I'm not sure if I'm the right person to be asked this kind of question, because I don't deal with this part of work, so I'm not sure. So
you using the robotic platforms, also like the exoskeletons. So I guess you had this opportunity to work with some low-cost technology, or you are always using just the state-of-the-art Vicon OptoTrack systems in the clinics?
We have, for the clinical work, we use Vicon system.
Yeah.
But we also have a similar motion capturing system, OptiTrack. We've seen in the previous talk that they use it to actually compensate for the drift of the measurements. This is also what we use. We have the system placed in our research lab. We also have been using the inertial measurement units.
Yeah. Okay, so the question here is like what we want to track. So if somebody is interested into time domain, for instance, to extract the information that we will be extracting in the next days when the hill strike occurred, then this drift, for instance, or not that reliable data that you get out of it from the space perspective could be still used for that specific analysis. But not if we want to create a 3D model or something like that.
Right.
Yeah.
So another example would be the HTC Vive that we use for motion capture, basically in the lab, which is a cost-effective system that is, compared to other like Vicon systems or camera-based systems, less expensive, but for our purposes sufficient, because we're not really interested in the fine-grained biomechanics, but rather gate cycle, and gate cycle information we can extract with such a system, right?
Yes, of course, I agree. So you can extract this kind of, let's say, gate event data, or the mechanisms also from this. Previously, when I said about using the other system in the clinical practices, that this is somehow also connected to how these systems are certified. So in the clinical use, you can only use systems that are certified for the clinical use. So this needs to be, let's say, slightly separated. In the research, actually, it's what is the aim of the research, and then you use the appropriate equipment. It doesn't really matter then.
Yeah. So before we had the question from the audience about the minimal requirements we have to track certain progress. So you nicely showed like examples how patients are improving. So to minimize or let's say take the minimum amount of sensors you would need to place in that setup, what would be the setup look, or how the setup would look like? Or on which feature would you rely the most? So do you need the EMG kinematics and kinetics, or can you track it with less sensoric systems?
Well, if you only want to measure the ground reaction forces without calculating the joint moments, then you don't need the kinematics. But I don't know if this information is quite useful, because you would want to have what is going on in each particular joint. So then you have to have the kinematics as well. So you have the kinematics and kinetics. So how do you measure these two things? So probably you can't really exclude the kinematic part. If this is sufficient, then you stop there. Otherwise, you would go and continue with the gate kinetics as well. So measuring the ground reaction forces.
No.
So.
Okay, then I would ask, try to trigger this discussion also in the directions. So Klaus, perhaps how do you see MOBI in the future adding into clinical practice? So where are the pros and cons, for instance, and how would you like to see it, let's say, in 5 or 15 years from now?
Yeah, well, I'm convinced that mobile brain imaging will contribute to a better diagnostic or evaluation of therapeutic interventions, for example, or diagnostic tools. So coming back to your example of stroke patients, right? So you do have training of stroke patients where you see an improvement in biomechanic parameters, but you don't know actually, or you don't know what's going on in the brain. Do we see plastic processes? Do we see changes in motor cortex, premotor cortex that is associated with that improvement of gait? And that would be, for me, very interesting from a basic research side of better understanding the human brain, actually, and how it can be trained, but also from the application, right? Can we then converge with additional markers from neuroscience that show there is actually an improvement, even though that might not show that drastically, but there is already something going on the brain level, like restructuring, changes in specific frequencies in specific areas that are a precursor to actual biomechanical improvements, for example. So this is something I think where mobile brain imaging can significantly contribute in the future for clinical practice. But it's just the other way around too, right? Clinical practice allows us to get access to rare patient populations. So it's a model that we can use in EEG research to better understand human brain and what happens if stroke, for example, eliminates certain functions. So this is very valuable for EEG research and better understanding and cognitive neuroscience in general.
Yeah, we can also say something about the new technologies or implementations of MOBI on toddlers.
Yeah.
So we've seen it in San Diego. They are doing research also in that field,
Yes.
which is really encouraging. And also from the other side, elderly Parkinson's disease patients and other clinical populations.
Yes.
So I completely agree with that. We are trying now to continue in the field towards clinical implementation, and with that, for instance, having like two groups which are not, but by a naked eye you wouldn't see any differences in their movement, also using the kinematical parameters, but perhaps, as Klaus mentioned previously, there are some cortical or spinal adaptations already occurring, and these like plastic changes that are basically going on that are not or couldn't be detected by simply behavior or biomechanics can be seen by cortical markers. Okay, so I was checking on the chat if there is like any other question from the audience. I think we don't have it here. So I would, with that, actually summarize what we've said until now. So I hope you could see this step-by-step progress. So where we wanted actually to show you what are the what is basic knowledge in terms of biomechanics, and then some applied version from the industry, how you can use these very complex systems streamed online, real time, and it works pretty well. So somewhere in between, I guess, your technology is currently, it's staying, so you are using it, and on the top of that, you can always move towards one or the other side. What we are looking forward or for the next sessions, for tomorrow, for instance, we're making a step forward towards the implementation or tracking the individual motor units. So from the muscle perspective, see how the central nervous system controls this movement. We will start basically very basic isometric contractions, so you actually see some force, or better to say torque production, but you don't see any movement from the outside, from the kinematical perspective. But still, you can detect those motor units, you can track them, and you can address this perspective from the fatiguing point of view. We know that Parkinson's disease patients fatigue quite easily, so when you trace them throughout longer sessions, you can see from the muscle perspective what is happening, but also then from the cortical next to biomechanical parameters. So that's happening tomorrow. We start at 9 o'clock, different link again, and then what we prepared for you for the last day, the third day of workshop, will be related to EEG analysis. So we'll be going into details how to clean EEG data, what is good enough, what is not good enough, how to extract or eliminate certain independent components to be prepared for different analytical approaches or analysis that we are using in EEG world. So event-related potentials, time frequency analysis, and cortical-cortical coherence, cortico-muscular coherence, and so forth. So with that, I would like to thank both of you and actually all the speakers of today, the audience, and everybody who is following us through YouTube channel. There are still, or the channel remains open, so you can still post some questions and we can discuss them tomorrow or after tomorrow. I'm encouraging you to do it so, and I'm looking forward to meeting you all tomorrow morning, 9 a.m. Thank you so much.
Thank you.
Thank you.